Oh, there we go. Whew. Okay, so today what we want to talk about more than anything is inverse functions. And I really want to highlight the word functions, okay? Because there's such a thing as inverse relations, but an inverse relation is just switching x and y, okay? So if I have an inverse relation, you go from x, y, and it becomes y, x, okay? So what makes the difference between an inverse relation and an inverse function? Well, I'll show you. Okay. If I have two examples, all right? Got a point there. I got a point right there, okay? So I have 2 points. I've got a point at -2, 2, and I've got a point at 1, 2, okay? So just the 2 points alone, that is a function, right? That's a function because we know that every x has exactly 1 y, right? That's definitely a function, right? The problem is if we switch the x and y's to get an inverse, so if I switch my x and y's, I would have then a point at 2, -1, 2, oops, sorry, 2, oh my goodness, 2, -2. Put this down in a different color. If I switch this point, this one becomes a 2, 1, right? Maybe you can see the problem. So what's the problem with the green points? It's not a function, right? Because you've got an x value and 2 y's, right? So it's relation because you still switch the x and y's, but it's not a function. Okay? So what we want to talk about specifically is an inverse function. So we'll say this, okay? Remember vertical line test, right? If it fails the vertical line test, it won't be a function, okay? If it fails a horizontal line test, it won't have an inverse. See how that works? That makes sense? So if it fails the horizontal line test, it will not have a function, okay? Because we see that you switch around. So to have an inverse function, okay, that's where the inverse x, y goes to y, x must be a function. And there is a test called the horizontal line test. So there's a test, and that's our horizontal line test. So up here, it fails the horizontal line test because we can see that when we find its inverse is not a function. So this one's a relation, not a function. Inverse relation, okay? Now, if I put any other points down, let me just go ahead and graph a line. Okay, so I'm going to graph a line. That's a function. This has an inverse. This one has an inverse because to have an inverse function, the inverse must be a function, right? So this one-to-one correspondence says this. Each point has exactly 1 y and 1 x. So the one-to-one correspondence, each point has exactly 1 x and 1
and one unique y value, okay? It's going to pass the horizontal line test and the vertical line test. It's going to pass both. Okay, so 1 to 1. It's going to pass the horizontal. It's not, this one's 2 to 1, and this one's 2 to 1. This one's 2 to 1. It has two values. It has two y values for one. No, I'm sorry. It says it has one y value for two x values. This one's 1 to 2. This one's 1 to 2, but this one's 1 to 1. Okay? Now, if that's the case, then in example 1, these are points. They don't look like points, but f of 5. These are points. So in a sense, if you plug in 5 for an x value, you get a 7. So that's a point, okay? So if we want its inverse, the x becomes the y. So the inverse of f inverse of 7 would be the 5. Okay, I don't want to make this too complicated, but think about this. Here's my f of 5. So they're saying, what's the inverse of the 7? So the 7 is the y. We make it the x. I'll say it again. What's the inverse of the 7? Well, the 7's the y. We make it the x. So the answer is 5. Thumbs up on that? That's not too confusing? Okay. Yes. Okay.
Say that again?
Yes. So the 7 is the y, right?
Right.
The inverse says make the y the x.
Oh. And the answer would be the what after that.
Right. So it's just switching them, right? The 7 is the y, and now we want its x value, and its x value is the 5. So you switch them, right? So the inverse of this point would be inverse of this point would be the 7, 5, right? Because we switch them. So we're going to look at the inverse of 7. It's got to be the 5, because the 5 became the y. Okay, now in the next one, if I take the inverse of 5, I'm sorry, if you take the inverse of 7, the inverse of 7's got to be the 5, right? Okay, so all I did is this piece right here. So if I take the inverse of 7, 7's the y, so then I get the x, okay? And now what's f of 5? Well, f of 5 has got to be the 7. See, there you go. You get it, don't you? Nice job, Malachi. There you go. Okay, example 2. So I want to go ahead and do it the old way, the slow way first, and then we'll talk about doing it the easy way. But first, if fx equals x minus 1 divided by 2. Okay, I want to graph this first. So I'm going to rewrite f of x. Let me rewrite this as a 1/2 x minus 1/2. You okay with that? I just divided by 2. It's just easier to graph. And there's a 1x here. It's just easier to graph. So I'll start at a negative half, and I'll do this one. I want to do two different colors, so I'll do this one in blue. Start at one, negative 1. Oops, start at negative 1/2. God, got it. And then up 1 over 2. Up 1 over 2. Ignore that point. Where's my whiteout? I'm making a mistake already. Look at that. Already a mistake. There you go. So I'm going to graph that line in, okay? Okay, now let's graph this one. Let's graph g of x. And what color do I have? Oh, I got green, okay? G of x is easy to graph. G of x is a 2x plus 1. So start at 1, up 2 over 1, up 2 over 1, up 2 over 1, okay? Okay, so then the directions are saying they're inverses. Okay, they're saying, hey, they are inverses of each other, okay? Well, how do I know that? Okay, how do I know that? Well, one way to do that is to switch x and y, because that'd make us inverse. So I'm going to take this example. I'm going to take f of x, and I'm going to switch x and y. Now I know fx is y, same thing. So I really have like this y equals really an x minus 1 over 2. Because f, x, and y are the same thing in this class until we get to some crazy stuff right now. So what I'm going to do is, if I can switch x and y here and make it look like this one, I'll say it again. I'm going to switch x and y, make its inverse, and if it turns out to be this equation, then I'm going to show its inverse, okay? So again, I'm going to switch x and y, and somehow I'm going to try and make it look like that. Okay, I'm going to do that. I go x equals y minus 1 over 2, okay? All right, let's solve for y. Solve for y. Okay, so multiply by 2. Right? I'll subtract 1, and I'll get a y equals 2x minus 1. Okay? Oh, golly. There's my second mistake today, huh? Plus 1. There's my second mistake. I hate making mistakes. So, I just made it. Are they the same example? Are they the same problem? Yeah, so they have to be inverses. So what I did, to back up one more time, is it said they're inverses. So I thought, okay, if they're inverses, I'll switch the x and y's, which I did, and then I simplified it and showed that they were the same exact example. Now we also learned last year that if you have an inverse, they are a reflection over the line y equals x. This point would fold to there, this point would fold to there. You can see how they fold onto each other, okay? Okay, turn the page. All right. So example 3. Let's graph this, and I know better. I'm going to use a pencil because I know I'm going to have to erase. Okay, just trust me on this, okay? So I'm going to graph 4 minus x squared. And you can use Desmos, but I just happen to know what it looks like because, you know, I've been doing math forever. 1, 2, 3, 4, 5. Okay, so how did I do this? You guys remember how to graph parabolas? I started at 4. And since I'm squaring it, it's upside down. I'm going to go 1, 1, because 1 squared, I'm going to go 2. 4, because I squared the 4, and I'm going to go 3. 3 squared is 9, so it went down to 9, okay? And then negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is, right? You okay on how we did that? And again, if you want to look at Desmos, you can look at Desmos. But I can do this faster than Desmos, okay? Now, I look at this problem, and as far as inverses, I see a problem, okay? Inverse, I see a problem. Can you tell me what's the problem with this graph and an inverse?
It's going to fail the vertical line test.
You guys agree it's going to fail that horizontal line test? So this thing has, it has no inverse, okay?
For a question then.
So down below it says, is the inverse a function? No. No, it's not, right? That's not a function because what would happen, and I'm just going to draw it with my finger so you can see it, it would be a sideways parabola. Actually, it goes this way. Look, a sideways parabola, okay? And we know that a sideways parabola would not be a function. You guys agree with that? It looks something like this. Watch my finger. So when I flip this thing, it'll look like that, okay? Now, let's fix it. Let's give it an inverse. So how do we fix it? Let's change the domain, okay? So if I could erase this back half of my graph, just erase it, right? Then it would have an inverse, right? You guys agree with that? But you can't just erase. This is math. So what did I do? I changed the domain. So in the original, I said, let's make the domain so we have x is only greater than or equal to 0. By saying that, it allows me to only talk about the positive half of this graph, right? Here's my x-axis. I have only positive values, my x, and I don't have any negative values, so in a sense, it's like mathematically erased, okay? All right, now, I have a function that has an inverse. Well, let's graph the inverse. So one way to graph the inverse is take my points, 0, 4. I got a point here at 1, 3. I got a point here at 2, 0, and I got a point here at 3, negative 5. And if I wanted to, and we did this last year, if I wanted to find the inverse, or last semester, I switch them, right? So I want my inverse points. I'll have a point at 4, 0. I'd have an inverse point at 3, 1. I'd have another inverse point at 0, 2. And I have a fourth inverse point at negative 5, 3. Okay. And if I had this line of, they fold over, there it is, okay? So you can see it fold. Now, what's the equation to this line? Well, what we can do to find the equation is we switch x and y. So we want the equation of the inverse. Let's switch x and y. Okay, we're going to switch them around. So my original question was f of x equals 4 minus x squared, right? But of course, fx and y are the same thing. You okay with, I mean, right? Fx, y are the same thing. Just a fancy name for y, okay? Because it is a function. So let's switch them. So what I'm going to do is rewrite this as x equals 4 minus y squared, okay? How am I doing? Well, that's the inverse, but it's not a very good looking answer. That is technically the inverse, but let's solve for y, okay? Let's solve for y. Okay, solve for y. Let's see, I'm going to go minus 4, right? X minus 4 equals a negative y squared. Okay. That's like a negative 1. It's invisible. So I'm going to divide by negative 1, divide everything by negative 1, which would make a negative 1x plus 4 equals y squared. How am I doing okay? Am I going too fast? Now we're going to square root it, right? But here's the key.
Uh-oh, we got a 9.
Well, we would, except for we're going to be smart about this. Because we would have an I if we allowed this bottom half. But we're not going to, because when we square root it, we'd normally have two answers, right? We'd have a plus or a minus. But we're not going to have plus or minus. We're only going to have the positive half, because we didn't graph the negative half, did we? So we're going to say, it's just the positive square root. And do you mind if I switch this around? It just looks nicer. You okay with that? And that's the inverse. So now the last thing I'm going to write is this. I'm going to say f inverse of x is the square root of 4 minus x, okay? So instead of y, I just found the inverse, so I just wrote as f inverse, okay? How's that? Okay? Now, the cool part is today we got lots of time to get some homework done. We got like almost 20 minutes, right? So the homework is page 149, 1, 5, 6, 11, 16, 21, and the exercise 24. So again, I do not give a lot of homework. I think you agree with that. I don't give a lot. You don't need a lot, but you just need to do it, right?